Hello everyone, and welcome to A1 Tutor Live class. And right away, we are going to be having physics. Welcome once again to our physics class. I believe everyone can hear me properly. We're about to kickstart today's topic, and I want to be sure that we are actually hearing my voice. So if you can hear my voice, please, you can give an emoji, send an emoji in the chat box, or thumbs up, or just type yes as a response in the chat box so we can proceed. If you can hear me, send a response in the chat box that yes, I can hear you, or an emoji. If you can hear me, please kindly respond to that message in the chat box. You can hear me and you can as well see the screen. Kindly respond to the message in the chat box. Okay, a recap of what we did in the last class. Last class, we were discussing the topic motion, and we defined what motion was, and we also considered the types of motion by using diagrams to explain each of those types of motion. And today, we are going to continue the topic again, the topic motion. Today is the continuation of that topic. So what are we going to discuss about today? We're going to discuss about a type of motion which we didn't mention in the last class, and that is what we call a relative motion. A relative motion. A relative motion. If you can hear me, please kindly signify. We'll be discussing today a relative motion. A relative motion. Okay, to explain these terminologies, a relative motion, we are going to make use of a diagram so as to make the definition easier to understand. What do we call a relative motion? We are going to consider a diagram. Okay, so we have a diagram in our charts. So we want to use that diagram to explain what a relative motion is. Let's consider this diagram together. Now, this is a relative velocity of moving objects. Now, with this diagram, we are going to explain the meaning of relative motion. The meaning of relative motion. So, relative motion can be defined relative motion relative motion can be defined as the motion as the motion of a body, the motion of a body with respect, with respect, with respect to another. A relative motion can be defined as the motion of a body with respect to another. Now, the diagram we have here is representing two vehicles or two cars moving in an opposite direction. Two cars moving in an opposite direction. So the and the car labeled as B is also on a motion. Is also on a motion. So what we call relative motion is the motion of the car labeled as A with respect to that of B. With respect to the car of B. So the motion of the vehicle or the car labeled A with respect to that of B is said to be a relative motion. The motion of car A with respect to the car labeled as B is said to be the relative motion of A. The relative motion of A. So the relative motion that we are discussing about has to do with two objects or two body in motion. Two objects or two body in motion, and they are related together. So it is defined as the motion of a body with respect to another body. So in this diagram, we have car A representing a body and car B another body. So both of them are in motion. So if you are asked to explain what car A, what is the relative motion of car A, what you're asked to do is to get the motion of car A with respect to that of what? B. And if you're asked to get the motion of car B, is going to be the motion of car B, the car labeled as B, with respect to that of what? Car A. Are we getting that? So that is what we call relative motion. It has to do with two body, two body in motion. And we are relating both body together when we are considering the what? The motion of each of them. Now, we are going to look at one other diagram to explain some facts about relative motion. We have like three facts to discuss under relative motion. And that fact is going to allow us to know how to solve questions under relative motions. That is the calculative part of relative motion. Okay, so I'm going to send another picture added to the one you have in your charts. Okay, we are going to have another picture. So this formula that I sent to us, we are going to be using it later after the explanation. So we'll keep that in our chat box. So let's have the picture to explain the fact of relative motion. All right, so the pictures are loading. We want to consider the fact of relative motion. So we are going to be using some diagrams to explain what are the facts, the key facts we have to know about relative motion. So to start with, let's start with this first diagram, relative motion. Now we said relative motion is defined as the motion of a body with respect to another body, with respect to another body. And take note that all objects moving on the surface of the earth has a relative motion with the earth surface. All objects moving on the surface of the earth has a relative motion with another body. All objects, be it human being, be it a car, be it anything, they has a relative motion with the surface of the earth, because the surface of the earth is considered to be a stationary object. So we are having a relative motion between a person running on the surface of the earth, having a relative motion with the earth, or a car moving on the surface of the earth also has a relative motion with the surface of the earth. Now let's consider this diagram. This diagram is depicting a train. We have two sections of it. This is the first section, and this is another section, right? Now, the first section, we have inside the train a boy sitting down, and if you check there, we have a boy sitting down inside the train. That means the boy is static. That means the boy is not taking any motion, right? He's static on a position. And the velocity of the boy was given to be what? V equals to 0. The speed or the velocity of the boy sitting was given to be V equals to 0, because no motion has taken place. But the train is moving, but the boy in the train is sitting. He's not performing anything like motion, right? And that is why the V was given as 0. That is, the velocity was given as 0. Now, for someone that is outside, observing the train moving, if such person is going to know the velocity or know the speed of the boy sitting inside the train, he's going to consider the velocity of the train, but not of that of the boy, because the boy is sitting in the train, is static, no movements has taken place. What is moving is the train, not the boy. So if the observer outside sees the train moving at this rate, 40 kilometers per hour, 40 kilometers per hour, that is, the velocity or the speed of the boy inside the train will be the velocity of the train. I believe you are getting my point now. I said that the velocity of the boy seated down in the train is going to be the velocity of the train that is moving. The train was moving at V equals to 40 kilometers per hour. So if we are asked to get the relative velocity of the boy, the relative velocity of the boy, the velocity of the boy will be equals to the velocity of the train. And it is so because the velocity of the boy will be equals to the velocity of the train, because the boy in the train is not performing any motion, is static. So his own velocity at that moment is 0. But if you are going to use the terminologies that has to do with relative motion, we said relative motion is the motion of a body with respect to another body. So the relative motion of the boy, the relative velocity of the boy with respect to the train, is going to be the velocity of the train. So the velocity of the boy also now will now be 40 kilometers per hour, because the velocity of the boy with respect to the train is equals to 40 kilometers. That's the first part. So the velocity of a static object is always equal to the velocity of the other objects in motion. The velocity of a static object is equal to the velocity of the other objects in motion. So the object that's static is the boy, and the object in motion is the train. So the velocity of the boy equals to the velocity of the train, equals to the velocity of the train. So that's the first fact we have to know about relative velocity or relative motion. I believe we are together. If that is clear to us, please let's signify. So we take the second point about relative motion. All right. So we're going to consider the second point. We're going to use the diagram again, another diagram to explain that. Okay, let's make use of this diagram now. All right, so we have another diagram to explain the second fact. Now, in this case, we have a boy running in the same direction with the train. Running in the same direction with the train. In this case, the boy is not static. The boy is also performing motion by running on the train. So he's moving in the same direction with the train. The train also moves in the same direction with the boy. So in this case, what is the fact we want to bring out is that when two bodies who have relative motions move together in the same direction, then the relative velocity or the relative speed of body A, which is the boy in this case, to that of the train, which is body B, is going to be the sum of their velocity. Let's explain that. The boy is moving in this direction. The train also is moving in this direction. So now, if you are asked to get the relative velocity or the speed of the boy to that of the train, is going to be relative velocity will be equals to the velocity of the boy plus the velocity of the train. Relative velocity will be equals to the velocity of the boy plus the velocity of the train, because they are both moving in the same direction. They are both moving in the same direction. So assuming that the velocity of the boy is 4 kilometers, an assumption, per hour, and that of the train is probably 10 kilometers per hour. So the relative velocity will be the addition of the velocity of the boy and that of the train. That will be 4 kilometers per hour plus 10 kilometers per hour. And that will give us 14 kilometers per hour. So the relative velocity or the relative speed is given as the addition of that of the boy plus that of the train. So that is the second fact about relative motion. So take note that when two bodies are in motion, and they move towards the same direction, the relative velocity or the relative speed is the addition of their speed or the addition of their velocity. I believe that is clear to us. All right, so that's the second points that we have derived from relative motion. All right. So we want to proceed to the next one, which is the last fact about the relative motion. So permit me to bring up another picture to explain what the third one will look like. From the picture sent to our chart, we'll be using another one. Okay, this time around, we'll be using this. All right, now we want to consider the third fact or the third point on relative motion. The third point on relative motion. Now, in this case, we have two bodies moving in opposite direction, not the same direction, but opposite direction. Opposite direction. So how do we get their relative velocity? The relative velocity of two bodies moving in opposite direction is the subtraction of their velocity. All right, so we have V, relative velocity, equals to the subtraction of their velocity. Subtraction of their velocity. So we are going to have, if we are going to consider the relative velocity of the vehicle labeled as B to that of the vehicle labeled as what? A, that's going to be the velocity of car B minus the velocity of car A. And we are taking the subtraction of both bodies because they are moving in opposite direction. They are moving in opposite direction. So when two bodies, when two objects in motion move in opposite direction, and you are asked to calculate or to obtain the relative velocity or the relative speed, what you have to do is to take the subtraction of their velocity. The subtraction of their velocity. So that is the third fact about relative motion. We take the subtraction of the bodies in motion. So this will give us the relative velocity of the two bodies, which is car A and car B. So we have discussed the 3 points, the 3 facts about the relative motion. The first one, we said the velocity, the relative velocity of a static body in another body that is in motion is equals to the relative motion of that body that is moving. That was the first diagram we considered about the boy sitting in the train. That was a static position, and the train moving. So the velocity of the boy is equals to that of the train. The second fact was that two bodies in motion moving in the same direction, moving in the same direction. The relative velocity or the relative speed will be the addition of the two bodies, their velocity and their speed. You add it together. And for the third fact, we said when they move in opposite direction, then we'll do the subtraction of their velocity or the subtraction of their speed. I believe we understood the 3 points that we have just derived from relative motion. If you are with me, kindly signify. And if that explanation is clear to you, please signify so we can proceed to the next work. Kindly signify. I'm waiting for a response. Just an emoji, thumbs up. If what we have explained is clear to us based on the 3 facts, that we obtain from relative motion, please kindly signify. Okay, Enoch. All right. So what we are trying to explain is that we are talking about a relative motion, and we stated 3 facts. That the first fact is that when an object is in static motion, that if an object is static and another object is in motion, and we are asked to get the relative motion of the object that is static, the relative velocity of that static object is equal to that of the object that is in motion. That was the first point. And the second point, if both objects are moving in the same direction, that is, both are in motion, you add their velocity together, or you add their speed together to get your relative velocity. And if they are moving in opposite direction, that is, they're not moving in the same direction, then you need to subtract to get your relative motion or relative velocity or relative speed. I believe that is clear. Okay, thank you, Enoch. Okay, I believe we can now proceed. Now let's proceed to the next thing we have on our agenda for today. Now we want to consider the distance between 2 points. If there's a movement from one point to another, we can have a distance between those 2 points. So let's consider how to calculate the distance between two given coordinates. Okay? So I'll clean the board. The distance between two coordinates. This is an aspect that usually come out in UTME exam, where you'll be given some coordinates and will be asked to find the distance between those coordinates. And coordinates can be represented on a graph. This is y-axis, this is x-axis. So let's assume we have a point here marked as P, and we have another point here marked as Q. So we have two coordinates, that is P and Q. P and Q. So how do we find the distance between P and Q as coordinates? They are both coordinates, and we want to get the distance between them. The formula we use is d, which represents the distance, equals to the square root of coordinate P is x1, y1, because we are dealing with a graph, and Q will be x2, y2. All right. So with these two coordinates given, we can find the distance. And the formula will be x2 minus x1 raised to the power of 2 plus y2 minus y1 close bracket raised to the power of 2. So this formula is going to give us the distance between two given coordinates. So let's take an assumption that we are given a coordinate that P is having the point 5, minus 2, and Q is having the point minus 3, 4, minus 3, 4. We are given these two coordinates, and we are asked to find the distance. You need to first identify x1, x2, y1, and y2. Because if the identification is wrong, you are likely to get a response that will not be accurate. So for this question, P is the first coordinate. This is x1, and this is y1. This is x2, and this is y2. So the first coordinate takes x1, y1. The second coordinate, which is point Q, is x2, y2. So let's go on to get the distance. In brackets, my x2 in this question, x2 is going to be what? Minus 3. X2 is what? Minus 3. All right. Then x1 is 5. But we have a natural minus in the formula. So let's have the minus first. Then x1 is what? 5. So we have 5, we close the bracket, square, plus, open another bracket. Now we want to consider y. Y2 is what? 4. Y2 is 4 minus, we want to consider y1. Y1, okay? So what is y1? Y1 is minus 2. Y1 is minus 2. So we have minus in brackets and close the bracket, square. D will now be equals to minus 3 minus 5 is minus 8 all square. That is, subtracting, we have minus 3 minus 5. The law says add them together and give it each sign. So we had 3 plus this together, that is 8. And the sign they possess, or the sign they are having, is minus. So minus 8 should be your response. Plus, for this, minus times minus we change to plus. Minus times minus we change to plus. We have 4 plus 2. 4 plus 2 all square. D will now be equals to the square root of minus 8 square is minus 8 times minus 8. And that will give us minus times minus is plus. 8 times 8 is 64. So we have 64 plus 4 plus 2 is 6. And 6 square is 6 times 6, which is what? 36. So we have 36. Adding 64 to 36, we have what? 100. And D now, which is the distance between two coordinates, will be equals to 10 units. 10 what? Units. 10 units. So this formula is what we use when we are asked to calculate the distance between two given coordinates. Two given coordinates. I believe that is clear to us. Calculating the distance between two given coordinates, I believe we have understood that part. Can we proceed? All right, okay. So please take note of the formula. I'll give you a question on it to solve during the evaluation period. Take note of that formula. D equals to the square root of x2 minus x1, or enclosed in a bracket, raised to power 2, plus, open another bracket, y2 minus y1, close the bracket, raised to power 2. So that formula will be used to calculate the distance between two given coordinates. Is that taken? Okay. So permit me to rub the board. Permit me to rub the board so we can take some question. Can I go ahead to rub off the board? So we'll move to the calculation aspects. Okay, all right. So we have some questions here to solve. Do not forget last class, or the first topic we did, which was fundamental quantity, we discussed about so many quantities. And there also we made mention of quantities like acceleration, velocity, speed, and all that. Today, we are going to apply those quantities in calculation under this topic, motion. So take note, I've sent you a formula sheet in form of picture here inside the charts. I've sent like three of them for us to use to solve these questions. So we are going to be considering some questions, and we'll be referring back to these formulas we have in our charts. Okay, so to start with, let's consider application 1, that is calculation under motion. The first calculation under motion. under motion. Okay, up one. All right, so let's consider this question. The distance x meter traveled, okay, traveled by a particular, traveled by a particular, traveled by a particle, rather, traveled by a particle in time, in time t seconds, in time t seconds, in time t seconds is described by the equation, is described by the equation x, which represent distance, equals to 10 plus 12t squared, full stop. Find the average speed, of the particle, when t equals to 3 seconds. When t equals to 3 seconds. Application 1. The distance x meter, take note, the distance was represented by x, traveled by a particle in time t seconds, is described by the equation x equals to 10 plus 12t squared. Find the average speed of the particle when t equals to 3 seconds. Our UTME question 2012. All right, now let's break down the question so we can solve it. We are asked to find average speed. Average speed. And average speed for this question we are solving, they are still referring to getting your speed. What they are referring to is that we should get our speed. And what is the formula for speed? The formula for speed is given as displacement, or we say time, distance, let's use it as distance over time taken. Speed is equals to distance over time taken. Distance over time taken, which implies change in distance over change in time. Change in distance, and in this place, distance is represented by x. So let me use change in x, which is your distance, over change in time. Change in distance over change in time is speed. All right? So we're going to make use of that equation to get our average speed. We're going to make use of that equation to find our what? Average speed. So let's go to have that. We have the equation is x equals to 10 plus 12t squared. X equals to 10 plus 12t squared. All right, so since we said it is change in distance over change in time, now we have to simplify this expression by getting the change in distance over change in time. Change in distance over change in time. So how do we do that? If speed is equals to change in distance over change in time, which is also the same thing as this symbol, change in distance over change in time, that means we have to apply what we call differentiation. Differentiation in mathematics or in further maths is the process of getting a derivative of a given function. Okay, so we have the function here x, which is representing speed, which is representing distance. X is representing distance, and we have it's given in terms of what time, which is what t. So if I'm going to get the x, which is change in x over change in t, what we have to do is to apply the law of differentiation. Now, take note. I'll quickly explain what differentiation is all about. When you differentiate a constant, when you differentiate a constant is a number without it. A constant. Your answer is always 0. The differentiation of a constant is 0. So if I differentiate 5, my answer is what? 0. If I differentiate 4, my answer is what? 0. So if I differentiate 10, what will be my answer? Of course, it will be 0. Plus, if I want to differentiate this, 12t squared. Let's explain how we can differentiate this. To differentiate this, we have to take this power and multiply 12. So we are going to be having 2 times 12, all right? Then we are going to have the t, which is the alphabet we have in that expression, and the initial power, which was 2, we write it as 2 minus 1. You have to take away 1 from the power. If I multiply this, I will have 24t raised to power 1, which is also 24t. So the differentiation of 12t squared is going to give us 24t. 24t. I believe we understand how we did that. It's just for us to multiply 2 by this 12, 24, and take away 1 from the initial power. Then you have your value already differentiated. So this will give us 24t, which implies that dx, which is change in distance over change in time, is equals to 24t. And that is also the speed from the formula. The speed is equals to 24t. So now let's get the final answer. The question gave us that t is equals to 3 seconds. When your time is given to be 3 seconds, what is the average speed? When your time is given to be 3 seconds, what is the average speed? And we are going to substitute time. The time given in the question, which is 3, that will be 24 times 3. And that will give us 72 meter per seconds. So the speed is 72 meter per seconds. The speed of this expression given to us is 72 meter per seconds. 72 meter per seconds. I believe this application is clear to us. Please take note, in case your time is not given in seconds, you have to convert it to seconds before you can solve your question. Because time is always measured in seconds. In physics, we consider time to be measured in seconds, not minutes and not hours. So if you are given in hours or in minutes, you need to convert it to seconds before you can use it in your calculation. Okay, is this application clear to us? So we take the second application. Okay, thank you, Enoch, for your response. So permit me to clean the board so we can move to the next question. I'll be rubbing off the board now. Okay, so up two is going to be a question under relative motion. Under relative motion. So we have two trains are moving in parallel track. Okay, I'll use diagram to do that. This is the first train. train A, another train again, this is moving in this direction, another train also, this is train B, also moving in this direction. Okay, train A is moving at 30 meter per seconds, and train B is moving at 40 meter per seconds. Find the relative velocity of train A to train B. So that's the question. We are given train A moving at 30 meter per seconds and train B moving at 40 meter per seconds. And we are asked to calculate the velocity, the relative velocity of train A to train B. Take note, they are both moving the same direction. Oh no, this will take us back to the fact we discussed under relative motion. So I want us to solve this. What will be the answer for this question? They are both moving in the same direction. What will be the relative motion of train A to train B? I'm waiting for a response in the chat box. When they are both moving in the same direction, what will be the relative velocity? "70. Awesome. A great response. Well done, Enoch. That's a great response. The answer will be 70 meter per seconds. 70 meter per seconds. Well done, Enoch. Okay, so how did he get that response? We said earlier that when two bodies are in motion and they are moving in the same direction, to obtain your relative velocity, you add up their what? Velocity. So we are going to have it solved this way. Relative velocity equals to the velocity of A plus the velocity of B, which is equals to 30 plus 40, and that is 70 meter per seconds. 70 meter per seconds. 70 meter per seconds. Okay, now let's consider another question again under relative velocity before we move to evaluation. Under relative velocity, let's consider another question. I believe this application 2 is clear to us, so we can take another one. Okay, thank you, Enoch, for your response. Okay, so application 3, app 3, two cars, car A and B, are moving in opposite direction. Two cars, car A and B, are moving in opposite direction. So let's use diagram to also illustrate that. This is car A moving to this direction, then another car B moving to this direction, and car A is moving at 25 meter per seconds, and car B is moving at 15 meter per seconds. The question is, what is the relative velocity? What is the relative velocity of car A to car B? question mark. We are asked to find the relative velocity of car A to car B. Look at the diagram very well. Car A is moving in this direction, while car B is moving in this direction. Awesome. All right, so Enoch has given us an answer. He said 10 meter per seconds. All right, let's solve it together. Let's solve it together. We have two bodies in motion, working in opposite direction. And the fact we got from relative motion was that we have to subtract their velocity. When they are moving in opposite direction, we need to subtract their velocity. So we have the relative velocity to be equals to the velocity of A minus the velocity of B. And that is 25 meter per seconds minus 15 meter per seconds. 15 meter per seconds. And that is 10 meter per seconds. 10 meter per seconds. All right. So that is going to be the response for this question. Okay. So now let's consider some question for evaluation. We'll be doing it together. I'll be giving us some question and we are going to work hand in hand to get the response. Okay. So permit me to clean the board. Permit me to clean the board. Evaluation. Question 1. A car accelerates at 10 meter per second to 30 meter per second in 5 seconds. What is the acceleration? A car accelerates from 10 meter per second to 30 meter per second in 5 seconds. What is the acceleration? What is the acceleration? Now let's look at this question together. First, you need to underline your parameters. We are given from this to this. In what time? In 5 seconds. So if you are going to solve this, you are going to write out parameters. The car started the journey from 10 meters per second. And that is considered to be the initial velocity. The initial velocity represented by U. Initial velocity is 10 meters per second to 30 meters per second. That means the journey of the car stopped at 30 meters per second. And that is the final velocity. The final velocity of the car, which is represented by V. We use V for final velocity, 30 meters per second. And it is done, that journey was done within the time 5 seconds. So T is 5 seconds. And we are asked to calculate the acceleration. Acceleration. So acceleration, if you check the formula in our charts, we have our formula sheet. Yeah, we have some formula given to us here. One of the formulas states that U plus AT, U plus AT, V, the formula states that V equals to U plus AT. Now, why do I have to use this formula? Let me tell you the reason behind it. When you list out your parameters will help you to know which formula to use. The question is that we should find acceleration. And in these parameters, we have letter U, letter V, letter T, and letter A. And look at the formula I'm using, V, U, T, and also what? A. So the best formula to use is this formula to get the acceleration. V in the question is 30 equals to U is given as what? 10 plus acceleration is not given. So we have it as A, but the time was given to be what? 5 in brackets. So we have 30 equals to 10 plus, when you multiply this together, we have 5A. By simple knowledge of mathematics, you need to collect the like terms. So if this guy moves to this place, we have 30 minus 10 equals to 5A. And subtracting 10 from 30, we have 20. 20 equals to 5A. And for us to obtain the value of A, which is the acceleration, we need to divide both sides by the coefficient of A, which is what? 5. That is going to give us 20 over 5 equals to 5A over 5. All right? So we have 5, we cancel 5, and we are left with A equals to 20 over 5. A equals to what? 4. So the value of A is 4 meter per seconds. 4 meter per seconds. Take note, in physics, your unit is very important. You cannot solve physics question without making use of your units. So ensure at the end of your solution, you have your units in your final answer. So the answer for this question is 4 meter per seconds. 4 meter per seconds. Acceleration is equals to 4 meter per seconds. All right, is this question clear to us? Okay, Enoch, thanks for your response. Okay, very quick one. I'm going to use the same question, but I'm going to change something in the question. And I want us to tell me what to do, the right thing to do while solving. Just a response of what to do while solving. Assuming that this was not given as 5 seconds and we have it as 1 minute. 1 minute. Okay, and we are asked to solve for the acceleration. What is going to be our time? Our time now is not 5 seconds again. What will be our time for this question? If the time was given as 5, if the time was given as 1 minute, what will be the time for this question? I just need the time. If the question stated that it was done, the journey was done within 1 minute, so I've cancelled this out, and this was given in the question, what will be the value of time when you are solving? 60 seconds. Great. 60 seconds. That will be the time. Because I told you earlier that in physics, we don't use time to be in minutes or hours, always in seconds. And these are the tricks that UTME do bring in their question. They already know that most students will be eager to solve. So they will just go on to plug in the value 1 as their time. And with that, you are likely to get the answer that is not accurate. So always take note that you have to convert your time from minutes to what? Seconds. So this will be 60 seconds. This will be 60 seconds. I believe you understand that. So that is very, very important. Take note of your question. Understand each of the units before you go ahead to solve your question. Today, we are able to discuss relative motion, and we brought about 3 facts about relative motion, which we also use in calculation. We applied those 3 facts to calculation. We also discussed about how to calculate the distance between coordinates, right? We did that also, and we also gave us the formula to calculate the distance between coordinates. We said the formula is given as d, the square root of x2 minus x1 square plus y2 minus y1 close bracket square. So we said this is the formula to calculate the coordinates of a given distance, of two given distance. And we went ahead to solve questions that has to do with motion. We went ahead to solve questions that has to do with motion. So I'm going to refer us for more practice question to the A1 Tutor app. If you understood what we've done today, please drop your favorite emoji. If you understood everything we've discussed today, thumbs up or drop your favorite emoji. Okay, thank you. Thank you. Thank you for your response. So please do not forget, practice make perfection. And for that reason, you need to always be conversant with your A1 Tutor app. Make it your friend. Ensure you solve questions on daily basis. Go to your A1 Tutor app, solve questions under physics that has to do with motion, and also with all other subjects. Of course, we have UTME questions that are related to the topics we have been treating so far, both in physics, in mathematics, and biology and English. So ensure you practice those questions. You see, the more you practice, the more you become a perfect solution provider. Are you understand what I'm saying? So keep solving questions, and even though if you are not correct in some cases, the app will supply you with a detailed explanation, which is going to help you to understand how to solve next time when you see the same question. So do well to solve questions using the A1 Tutor app for any subject. You have it there on the app. So make the app your friend. And if you want details video about this topic, motion, is also on the app. Check SS1 as a class. You have motion. Watch a detailed video. And also, please do not forget, do well to share with your friends these benefits you are getting. Share the app you have on your phone, which is the A1 Tutor app. Recommend it for your friends also to use. And also, you can tell them that if peradventure they've not been chance to partake in the live session, of course, they've not missed. They should just have to go, they just have to go to the YouTube channel, search for A1 Tutor. A1 Tutor. Okay, so you have all the videos of the previous classes we have taken on live session. So you can watch and enjoy and learn smarter. Okay, thank you for your time today. Tomorrow is another day. Ensure you are making yourself available for the class. Do not miss any part of this live section. Thank you. See you tomorrow.